Hi, in this problem we're going to integrate the natural log of x divided by the square root of x. To do this, we're going to use something called integration by parts. And the reason we're going to use parts is because it seems like a way to do it. If you just make a regular u substitution, it's not going to work. So the integration by parts formula says if you have the integral of u dv, this is equal to uv minus the integral of v du. So in these problems, we have to pick our u and we have to pick our dv. So u is the piece we're going to differentiate. Notice there's a du here. And dv is the piece we're going to integrate. Notice there are v's here. So in this problem, we have ln x, and it's much easier to differentiate the natural log of x than it is to integrate. So we're going to let u be equal to the natural log of x. And then dv is whatever's left over. So it's just basically dx over the square root of x. So I'm going to go ahead and write that. dv is equal to dx over the square root of x. Okay, so let's differentiate u equals ln x. That's pretty easy. That's just 1 over x. And don't forget the dx. And now we have to integrate this. So let's just take a moment here to think about that. So we're looking at basically 1 over the square root of x dx. That's what we're trying to integrate. So we can write this as 1 over x to the 1/2 dx. And the reason we're doing that is because now in the next step, we're going to take this and we're going to bring it upstairs and write it as x to the negative 1/2. And that's important because now we can apply the power rule, which basically says we add 1 to the exponent and divide by the result. Adding 1 to negative 1/2 gives us 1/2, and then we divide by 1/2, and then we have our constant of integration, capital C. That's the same thing as 2x to the 1/2 plus c. And the reason it's the same is because when you divide by 1/2, you really multiply by the reciprocal, which is 2 over 1. So here we just write 2x to the 1/2. You don't write the plus c. So just a side computation here. If you can do it in your head, do it in your head, that's fine. And so now we're ready to apply the formula, the integration by parts formula. I'm going to go ahead and write down our original integral one more time. It was ln x over the square root of x dx, and that's equal to uv. So uv, it'll be v times u or u times v. I'm going to put the v first because that way the number's in the front. So 2x to the 1/2 ln x, and then it's minus v du, so this times this. So integral 2x to the 1/2 times, and then 1 over x dx. Good stuff. So this is equal to 2x to the 1/2 natural log of x minus the integral of, here we can do some work. There's a 1 here. So because we have the same base, we subtract the exponents. We have x to the 1/2 over x to the 1. So you basically just subtract 1/2 from 1. 1/2 minus 1 is negative 1/2. This is 2x to the negative 1/2 dx. Again, if you have x to the 1/2 over x to the 1, you just subtract these and you get negative 1/2. Okay, now we can keep going. So this is 2x to the 1/2 natural log of x. And then here we'll add 1 to the exponent. So this is x to the 1/2 because negative 1/2 plus 1 is 1/2. And then we divide by the result. So divided by 1/2 plus our constant of integration, capital C. So we add this at the very end, right when we finish up. So this is 2. Let's go ahead and write this as the square root of x, natural log of x. Here, same thing. When you multiply, when you divide by 1/2, you're really multiplying by 2 over 1. So it's minus 4 square root of x plus a constant. That's a little confusing. Here's the intermediate step. I'll do it here. It's It's minus 2 over 1 times 2x to the 1/2. It's the intermediate step I skipped, because when you divide by 1/2, you multiply by the reciprocal, and then 2 times 2 gives you the 4 that you see here. I hope this video has been helpful. Good luck.